Hi everyone, this is Mr. Hall, and this is a really quick video about how to make soluble salts. I'm not going to talk a great deal about the procedure itself in terms of the individual steps you have to do in order to make a soluble salt from an acid and a base, but I'm going to talk a lot about just one or two of the key steps and the theory behind why you do those steps, just to make sure you're really clear as to why you do them, because they get asked quite a lot in exam style questions, whether you do an AQA at Excel or high school chemistry, whatever it may be that you're studying. So in terms of the objectives for today's sessions, there's basically two. The first one is to identify the reactants needed to create a given salt. This is kind of based on past knowledge, but it's something which is important and you do have to kind of mention in a question. And also I just want to explain some of the key steps in the formation of the salt. So let's start with the first one, the identification of reactants needed to create a given salt. When you are thinking of the two things you need to make a salt, they depend on two things. They depend on the acid that you use, and it also depends on the metal or the metal compound you react it with. So as an example, if we look at copper sulfate, so copper sulfate is one of these kind of classic compounds that students often have to make. If you look at the name, now the second part of the name is basically the part of the name which is the acid, okay? So the sulfate means that the acid that I need to use here is sulfuric acid, okay? So whatever I react this acid with, I'm always going to make a sulfate, and we'll come back to the solid that you react it with in a moment. So I'm going to use sulfuric acid. And then in terms of the substance I react that with, I've actually got lots and lots of different options. I'm not going to go through all the different options in the world of chemistry that you could use, but there's a few that you do need to be aware of. Now, the most basic one is just using straight copper, which you could use. Copper's quite unreactive, so it's probably not the kind of metal or metal compound of choice, but it's one that you could use. So copper's one of them. Another one that you could use is copper oxide, which is insoluble and would be quite a common one to use in this particular experiment. You could also use theoretically copper hydroxide. And you could also use copper carbonate, all right? And it doesn't really matter which one of those you use, all right? The key thing is that they all contain copper in one form or another. You're probably going to make lots of other different products. You might make water or hydrogen or carbon dioxide. I'm not going to get into that because that can be covered in other videos. The key thing you should be aware of is that they all contain copper. So that's the key thing. So the metal or metal compound contains the metal that you're looking for, which in this case is copper. And then the acid, it has to be sulfuric acid. You can't use any other acid like hydrochloric or phosphoric or whatever, because it's going to give you a different salt. Okay, so if we look at a few other examples, so if you look here, now sometimes in a question, instead of just saying from an insoluble base, how do you make this particular salt, they'll be a bit more specific. So for example, if you're asked to make copper chloride from an acid and a metal oxide, first thing I'll do is I think about my acid. I look at the second part of the name where it says chloride, so I know it has to be hydrochloric acid, which is shown here. And then if I look over here, I've got copper and it's from a metal oxide. Now I can't use copper or copper carbonate or copper hydroxide because I'm asked for an oxide. So it has to be copper oxide that you're going to use. Now if we try a different example here, sodium chloride from an acid and a metal oxide. I'm going to start with the acid because it's pretty much the easy bit. It's chloride, so it has to be hydrochloric. Just going to write it very quickly here. And then if I look at the solid that I need to react the acid with, I can see it says metal oxide. Now I'm looking for sodium to be in my salt, so I have to use sodium oxide. So over here I'd write sodium oxide. Okay, let's try a couple of more examples. Here I've got zinc sulfate, that's what I'm trying to make. So I need an acid and a metal carbonate. Let's start with the acid first of all. I've got sulfate, so it has to be sulfuric acid. And then if I look at the solid I need, so it's a metal carbonate, and that metal carbonate has to contain zinc. So it has to be zinc carbonate. Okay, let's try a couple more. I've got magnesium nitrate. I'm making it from an acid and a metal oxide. Let's do the acid first of all. Now I've got nitrate inside this salt. So the acid, it can't be hydrochloric or sulfuric because it says nitrate. So in this case, it's nitric acid. Just as an aside, if you're doing AQA, the three acids you definitely need to know is hydrochloric, sulfuric, and nitric. If you're doing like a really hard question, I might throw phosphoric acid in there, but they'll probably give you some help before they set a question on that. Now for the metal oxide, which I'm looking for, it has to contain magnesium, so it has to be magnesium oxide. All right, I won't trouble you with the last one, but it's the same procedure where you're looking for the acid, you're looking for the metal inside the insoluble solid, and and then you can kind of pursue it from there. So that's how you do that bit. Now let's focus on a couple of the other steps of making a salt. Now the first one I want to think about is, why is the acid heated? Now the reason why the acid's heated is to make sure that the reaction happens quicker. So this harks back to the unit on kinetics and reaction rates. Now when you heat up the acid, the reason why it goes quicker is because the particles have more energy, and that means that as a result that they collide more frequently, and then you have a greater proportion of those particles having energy equal to or greater than the activation energy. Now I'm not going to go too much into that because it's covered better in kind of videos and content which is specific about kinetics, but that is the reason why. And what you'll often find is a question talks about making a soluble salt, and then they might kind of sidewind into a question about rates, and that's traditionally how they would do it. So just be aware of that. And then the final thing I want to talk about is why you add things in excess, because if you've done the experiment, you would have added loads of the insoluble solid inside it, and then your teacher would have said do it until it, you can still see it even if you've stirred it for ages, and that means in excess. But what does that actually mean? Now the best way of me explaining that is you have to kind of be familiar with pH a little bit. Now let's have a look at the picture I've got here. Now this is sulfuric acid, and in sulfuric acid what you've got is H2SO4, which is the sulfuric acid molecule, and that is dissolved in water. All right, now because sulfuric acid is quite a strong acid, it has a very low pH, so we're looking at a pH of around 2. Now as soon as you start adding your copper oxide, which is this black solid that you're lumping in, it will go into your solution of acid, and then it will start neutralizing the acid slowly. So the copper oxide reacts with the sulfuric acid, and then it will make water, and it will make copper sulfate. Now the copper sulfate is the blue crystal, and that's dissolved in the water. That's what gives the solution a blue color. And you've also got water, which is made in the solution, and that's just there. So if I react kind of one lot, if you like, I'll have one lot of water and one lot of copper sulfate. I've still got loads of acid there, but because I've got less acid than before, it means the pH is creeping up ever so slightly. So now the pH might be around 3. Now, if you want to kind of represent this like a diagram, almost like a graph axis, you could think of it like this, where your graph starts a little bit like that, around pH of 2, all right, if this is the axis for pH. And then as soon as I start adding my copper oxide, it starts going up a little bit to about 3. So that's after my kind of first spatula foot, if you like. Okay, and then what you can do is you can add loads more, all right, because you want to get rid of all that acid. You want to fully neutralize it to make sure it has a pH of around 7. So here I am, I'm lobbing in all my copper oxide, and it reacts with all of the acid in solution like so, with each and every molecule. And then eventually, all of the acid molecules are going to react with the copper oxide. Now that's going to make a load of copper sulfate and a load of water molecules in solution. That is the blue solution you have. But you don't know when all of that acid has reacted because you haven't got this kind of amazing microscope to see when they've all disappeared. So that's why you have to add it in excess. So you have to add more copper oxide just to make sure all of the acid has reacted. Now, if you add more copper oxide than you need, it's got no acid to react with. So when that happens, it will simply just settle at the bottom rather than react with anything. And that's why when you look inside your beaker, it looks a little bit like this. It's kind of black stuff at the bottom. In this particular reaction, it's the copper oxide. Okay, that is your excess. Now, if we had to show it like a graph, it would look a little bit like this, where at the start, I can just draw it on this side. Oh, not really allowing me to do it. Let's do it over here. So your pH would start very low at around 2. Okay. And it will go up, 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 up until it reaches around pH of 7, and then it goes flat. That is effectively the pH profile for this reaction, where it starts off quite low at pH around 2. It will go up ever so slightly to the pH of 7, and when it's fully neutralized, it just goes straight. Okay, so that's why you add it in excess. Okay, and that's it. I hope that's been useful, and best of luck with your studies on this unit.